Purification of water is of great importance in a community, and it is considered under two headings, that is purification of water on a large scale and purification of water on small scale. Now the main objectives of this purification is to remove the dissolved harmful chemical agents and to remove any microbiological agents and to oxidize the organic matter and to prevent contamination after purification. Purification of water is done on large scales and on small scales. In large scales, certain measures are taken, that is storage. Storage helps in the purification of water, as about 90% of the suspended impurities they settle down in the 24 hours due to gravity. And chemically, all the aerobic bacteria usually oxidize the organic matter which is present in water with aid of dissolved oxygen. And biologically, tremendous drops take place in the bacterial count during the storage. Now, next coming to the filtration. Filtration is the second stage in the purification of water, and it is quite an important stage because 98 to 99% of the bacteria are removed by filtration. Filtration of water, as I told you, it is done by slow sand filters and rapid sand filters. Now, in slow sand filters, there are various elements of slow sand filters. Number one, there is a supernatant raw water level, which is usually 1 to 1.5 meters. And then there is a bed of graded sand. The thickness of that bed is 1.2 meters. Then there is another under drainage system below that sand bed. And then there is the filter control valves. Diagram shows a slow sand filter. As you see, there is a layer of raw water on the top. I told you the thickness or the depth of that supernatant water is 1 to 1.5 meter. This raw water, it serves two purposes, and it provides a constant head of water so as to overcome the resistance of the filter bed, and thereby it promotes the downward flow of water through the sand bed. And secondly, it provides a waiting time of some hours, that is round about 3 to 4 hours or even 12 hours, depending upon the filtration velocity, for the raw water to undergo partial purification by sedimentation, oxidation, and particle agglomeration. Now the level of the supernatant water is always kept constant. Then there is a layer of sand bed. Now the sand bed is usually 1 meter deep, and the sand is usually rounded. The particles of the sand are preferably rounded and effective diameter between 0.2 to 0.3 millimeter. Now, below the sand bed, there is a layer of gravel which supports that layer. And above the sand bed, it develops a vital layer, which is a biological layer, and it's called schmizdak. It is a slimy growth, and this is the heart of the filter, and it removes the organic matter, and it holds back bacteria and oxidizes the ammoniacal nitrogen into nitrates and helps in bacteria purification of water, and the water is then bacteria free. Now, below that, as I told you, then there is below the sand bed, there is a layer of support gravel, and from that layer, the water is transferred to the filter bottom through the control valves, and then it goes into the supply where it is disinfected by chlorination. Coming to the advantages of slow sand filters, they are very simple to construct, and very less trained staff is needed to operate it. and very less amount of money is also needed to install it. Now the maintenance cost is also very low. It adds to physical, chemical and biological qualities of water, and the total bacterial reduction rate is from 99.9 to 99.99%. This diagram shows a rapid sand filter. Now the rapid sand filter is of two types, the gravity type and your pressure type. Both these types are used. Now there are certain steps which are involved in the purification of water by rapid sand filtration. Number one step is the addition of alum to the pollutant water, and it is a chemical coagulant, and from that the water is transferred into the rapid mixing chamber, in which there is quick and thorough dissemination of alum throughout the bulk of water, which is very important. And then that water with mixed alum is transferred in the flocculation chamber, and in this chamber there is slow and gentle stirring of the treated water for about 30 minutes, and from that it is then transferred into the sedimentation tank, and the water is left there for at least 2 to 6 hours. Now all the flocculates, they combine with the pollutants, and those flocculates, they settle at the bottom, which are removed. Now water from the sedimentation tank, it is then transferred to the filtration unit, and from filtration unit the water is then disinfected, and then clean water supply is maintained. Now coming to the advantages of rapid sand filter, the rapid sand filter, it occupies a very small space as compared to the small sand filters, but it is very costly, and usually it needs operation by the trained staff, and there should be a facility of backwashing by backflow, which is easy, but it needs to be done frequently as it gets very dirty. Now there is removal of turbidity, color and bacteria from 98.99%, but its installation and maintenance is very costly as compared to slow sand filter. Water is disinfection of water, and we all know that disinfection is done by chlorination, as chlorine, it kills the pathogenic bacteria and has a germicidal effect. It oxidizes iron, magnesium and hydrogen sulfates and destroys any taste and odor producing constituents in water. It controls the growth of algae and fungi and helps in coagulation. Action of chlorine. When we add chlorine in water, there is formation of hydrochloric acid and hypochlorous acid. Now this hydrochloric acid is neutralized by the alkalinity of the water, and the hypochlorous acid ionizes to form hydrogen ions and hypochlorite ions, and the hypochlorous acid is the most effective form of chlorine for water disinfection. Now the disinfection action of chlorine is mainly due to the presence of this hypochlorous acid, and to a small extent due to the presence of hypochlorite ions, but the pH should be maintained at 7. Like when the pH exceeds 8.5, it is unreliable as a disinfectant, because that 90% of the hypochlorous acid, it gets ionized to hypochlorite ions. Chlorination. Number one, the water should be clear and free from any turbidity, as turbidity, it prevents the efficient chlorination. Second, the chlorine demand of water should be estimated. Now the chlorine demand of water is the difference between the amount of chlorine which is added to the water and the amount of residual chlorine remaining at the end of a specific period of contact, which is usually 1 hour, at a given temperature and pH of the water. And the point at which the chlorine demand of the water is met is called the break point. Now, third point is the contact period. There should be a contact period of at least 1 hour, which is essential to kill the bacteria and viruses. And the minimum recommended free chlorine level is 0.5 milligram per liter for 1 hour. Now, the chlorine demand is based on specific water conditions, for example, organic compounds, your pH, temperature, and plus free residual chlorine, which is usually 0.5 milligram per liter. For chlorination, chlorine gas is used. Other than that, chloramines and perchloron is also used. Orthotolidine test, it enables us to detect the free and combined chlorine amount in water. And here in this test, orthotolidine reagent is used, which is dissolved in HCl. 0.1 ml is added to 1 ml of water, and reading is taken within 10 seconds for free residual chlorine in water. In the previous slides, we have seen how we can purify water on large scale. Now we will study the purification of water on small scales. Now in households, it is done by boiling the water or by addition of chemical disinfectants like bleaching powder or chlorine solution or high test chloride. Iodine is sometimes added, or tablets of potassium permanganate were also used previously. Another method is by filtration, and the filters used are Pasteur Chamberlain filter, your Berkfield filter, and Katadyn filters. All these methods are used for the purification of water on small scales. Surveillance of water is very important, as we have to maintain the quality of drinking water. Now, certain activities are carried out for surveillance, which are: number one, the approval of the new sources; number two, the watershed protection; number three, the approval of the construction and operating procedures for the waterworks, which include the disinfection of the plant, the periodic flushing programs, your certifications of the operators who are going to operate that plant, regulation of the chemical substances and the connection control, your backflow prevention and leak detection control. All these things are included in when you get approval for the construction and of that new water source. Surveillance of drinking water is a health measure, and it is intended to protect the public from waterborne diseases. Now, the elements of a surveillance program are: number one, sanitary surveys are carried out, which are the on-the-spot inspection, which is done, and the evaluation is done by a qualified person. Then different samples of water are taken, and they are tested in the lab. And then bacteriological surveillance is also done, and to carry out the bacteriological surveillance, tests should be conducted, like presumptive coliform test, or the detection of fecal streptococci and Clostridium perfringens. Now, biological examination of water is also important. As we know, water can contain certain microorganisms like algae and fungi, which can cause pollution. So these all examinations are done for surveillance of water. Chemical surveillance of drinking water is also very important, especially in those areas where industrial and agriculture pollutants are mixed into raw water sources. And tests are carried out for pH, color, turbidity, chlorides, ammonia, chlorine demand, and residual chlorine. And these are the basic tests which should be done for chemical surveillance. Now we finish with water, and if you have any questions, you can ask me on Facebook, and Dr. Ikra will take your attendance. Thank you.